So in this video we're going to go over how to prove that a set of vectors are linearly independent. Excuse me. Essentially, if you have a set of vectors v1, v2, v3 dot all the way to vn, and certain coefficients for the coefficient set for these vectors a1, a2, a3 all the way to an corresponding a1 v1 plus a2 v2 all the way to an vn. If this equation equals 0, wherein all the coefficients are 0, then that means that those set of vectors are linearly independent. Essentially, if you set up the augmented matrix with the solution equaling 0, and there's only the trivial solution for the matrix ax times 0, where x is the coefficient matrix, then that means that those vectors are linearly independent. For example, we're going to prove vector 0, 1, 5, vector 2, 1, 2, 8, vector 3, 4, negative 1, 0 are linearly independent. So the first step is setting up the matrix equation. Vector v1, 0, 1, 5, vector v2, 1, 2, 8, vector v3, 4, negative 1, 0 times the coefficient matrix a1, a2, a3 equals 0. Now, if upon solving this matrix a1, a2, a3 are all zeros, then we have proven that these three vectors are linearly independent. So, after setting up the equation, the second step is to set up the augmented matrix and then use row reduction to solve for it. So, based on the previous step, this is the augmented matrix with vectors v1, vector v2, vector v3 set equal to 0, and then using elementary row reduction on it, we get to the solution to the row reduced matrix 1, 2, negative 1, 0, 1, 4, 0, 13, 0. Now from the matrix you can clearly see that a3 equals 0, a2 plus 4, a3 equals 0, but since a3 already equals 0, a2 also equals 0, and a1 plus 2a2 minus a3 equals 0, but since a3 and a2 equals 0, a1 also equals 0. And you can see right here that a3, a2 and a1 all equal 0. So by the definition, since the coefficient matrix all equals 0, we only have the trivial solution for this matrix, and therefore vectors v1, v2 and v3 are linearly independent.